the aim of this morning is to recap the dermis. So I know that you've done work before, you've been through the videos, you've done some recap, so we're just going to do another recap. So I've got some plain paper for you. So the first thing that we're going to do is show the overall structure of the skin. So if I drew, for argument's sake, 3 sections. 1, 2, 3. The top one is the epidermis, correct. Epidermis. The second one is the dermis. And then the bottom layer is the...
Is that the basement membrane?
No, not quite.
Is the flipping, I can't remember it. I'm thinking...
What does it begin with?
Sub.
Yes, sub, because sub means under. Subcutaneous layer.
Yes.
Okay, subcutaneous. Is there another name for it?
Epi something, is it? Epithelial or something?
No. No? Think about where it actually is. What type of tissue is it?
Connective, is it?
No, it's not connective tissue.
Adipose.
Adipose tissue. What's another word for adipose tissue?
I'm thinking fat.
Yes. So it's also, from a tissue point of view, it's adipose, which is also fat cells. So I digress just a fraction, but I'm going to put some fat cells.
Yes.
But the actual layer we call something that sits over the top of the skin.
Matrix. Acid
Not
mantle.
quite. Acid mantle. Acid mantle is a combination of the, what, 2 different types of
Fatty
fluids.
acids and lipids, is it? Or sebum and...
Sebum, so fatty acids, yes, in a certain way, because that's your sebum. And what else do we excrete from the skin?
Sweat. Salt
Yes.
use, yeah.
Yes. Yeah, so water and sweat comes together. So you've got the acidity, which creates the acid mantle, which creates the waterproof covering, but also the protection, slightly harder protection. Anyway, I digress. We're looking at dermis. So, how many layers or how many regions are there in the dermis? Okay. Can you remember the name of the 2 regions?
Reticular.
Yep.
And I've forgotten.
Papillary.
Well done.
Yeah.
Reticular and papillary. Okay. And what type of tissue is this, particularly in the reticular area? You mentioned it earlier. Connective tissue. And what does connective tissue do?
It gives structure.
Gives structure, gives substance, gives connection, basically. Yeah? Okay. How do you remember that the papillary is at the top, the reticular is at the bottom?
I don't.
Okay, so there's lots of different ways that you can remember it when you understand the function, but a very simple one is P becomes before R.
Oh.
So P's at the top, R's at the bottom. If you can't think of it for any other way, then think of it like that. So let's have a little look now at the functions of the skin, because the functions of the skin are actually going to remind us all of the bits that go into it, and we're going to draw it. So can you draw your 3 areas? And can you write down the side or on the back of it if you want a bit more room? The acronym SHAPES. SHAPES.
Where we're doing that.
Oh yeah.
Wherever you find you've got a bit of room, or you can do it on another piece of paper or on the back. Good.
I know this.
Sensation.
Okay, so if we use this acronym whenever we're trying to remember about the dermis. So what does the S stand for?
Sensation.
Sensation. How do we feel things? Nerve endings. Okay, how many types of nerve endings do we have in the body? We have 5. You don't have to know what they look like, you don't have to know what they are, but you just need to know that there are pain, pressure,
Oh, okay.
heat, cold, and sensation. So think about what you feel. You can feel if something is smooth, if something is tickly. You can feel when somebody's close to you. You can feel a breeze. You can certainly feel if somebody slaps you.
Yeah.
You can feel whether something is a light pressure or a really deep pressure. So the type of nerve endings work slightly differently. And Emma, for you at the moment, you don't have to do the nervous system. Jackie, I know you've already covered it, which is why you've got a bit more knowledge. But they all look sort of slightly different. So we've got pain ones that sort of look like that. Once upon a time, I'd know all the names off my head. I can't remember them now. They've all got very long Latin. I think they're Latin or Greek names. Or they might be like that. Or they might be like that. But the most important thing is that they are at different stages of the body, or the dermis, so that we can detect. So where do you think the pressure ones are going to be? Higher or lower?
I think they're gonna be
Lower?
They could be lower because that's how you detect, you know, deep pressure. Or they could be higher because that's how you detect low pressure. So they're going to be all throughout. Yeah. Your sensory nerve endings, so the nerve endings that tell you sort of what's going on, the feelings that you get, are going to be very, very close to the surface of the skin. So they're literally going to be up here. And where else do we have those nerve endings? Think about what we talked about last week.
At the end of the bulb of
The hair. So if the hair gets pulled out, we know, and that's why we feel pain. But we can also feel traction. We can feel if it's being pulled. So there's pressure, there's pain. So let's put in a hair while we're about it. So this layer here is the what layer?
Epidermis. Oh, the stratum, the base layer.
The base layer, so the stratum corneum. Germinativum. Excellent. Not corneum.
I can't ever say that, but it's just...
So that goes down and creates this indentation, doesn't it? And we won't draw the hair in its entirety, because that was last week's, but just to remind you, in here we have our basal cells go through a process of mitosis. Eventually, keratinization process happens about here. Okay, and round the bottom we have lots of little...
Am I meant to be doing colours here?
Well, are you a colour person? I'm very much a colour person. So for me, when I do my course structure, my purple is always waxing. My orange is always manicure and pedicure. So if I've got a spreadsheet, I can kind of see where things are. I learn through colour. Some people don't. Doesn't make any difference to them. So if you are a colour person, do it in colour. Might mean a bit more to you. Okay, so we've got our S, which is sensation. Sensation is caused through nerve endings. We know that there are a number of different types of nerve endings, and they are in different places depending on whether that sensation needs to be heat, cold, pressure, pain, or texture. So we can feel if something's smooth, can't we? And that's all to do with the interpretation, but we don't need to go into that now. Okay, so what's H?
Heat, isn't it?
Heat, yes.
Heat.
So heat
Regulation,
what?
So it
Good.
modifies your temperature.
Heat.
body temperature.
Regulation. Okay, so there's a couple of ways in which we regulate our heat. The first one is what happens when we get cold.
We get goosebumps and shiver.
Okay, goosebumps and sugar. Shiver. Excellent.
Our hairs stand on
Hairs stand on end. That's our goosebumps and shiver. Let's deal with that one then first. Then, how does that actually happen?
It's
What's the mechanic?
Erector muscle
Yep.
contracts and makes the hair.
Excellent.
stand.
So on the
Attracts warm
side
air.
then, on the side here, I'm going to draw it on here, we have a little muscle. And that muscle is called the erector pili muscle. and it sits sides of the hair follicle to the underside of the epidermis, and when it contracts through the nerve endings, stimulating it to contract, that's the motor part of the nervous system, it shortens, which is what happens when muscles are stimulated. By shortening it, it pulls this out and it makes this hair stand upwards. I can't draw that very easily, but it does. It pulls it forward and it makes it stand up. Because actually our hairs don't stick out like that, do they? They lay down on the skin, so they would then stick up. Why does that happen? What's the point of that?
To trap warm air in between, so obviously
Absolutely.
we generate heat and then that helps to keep retaining.
It does. So we generate heat. How do we generate heat? Why are we generating heat? What causes that process in the body generally? So I'll go to you, Jackie.
Metabolism.
Yes, so your metabolism, the way in which you work, even just by walking across the room, you are generating a lot of heat in the body. So all of our organs, when they are working, they generate heat, which is why if you're cold and you jump up and down, you will create heat in the body.
You're expending energy, really, aren't you?
You are expending energy, and where is that heat kept, retained, moved to? What transports the heat?
Your blood.
Muscles create it,
Your blood,
but
your
it
blood,
travels
your
through
arteries and-
the arteries to the various organs that you need, that need the warmth as well as everything else. So, do you think it's in the capillary or the reticular layer?
I think it's in the reticulary in particular. That's where all the arteries will be.
Okay,
and all the veins
so
and that.
arteries. So let's draw in a nice little artery along here. So arteries have nice thick walls, muscular walls. But what comes off those arteries?
Your veins.
Do they?
Oh no, not your veins.
Emma, what comes off an artery? Think about your road
Capillaries.
system.
Sorry.
Capillaries, yes. So capillaries and arterioles. So if you think about the blood supply being like the road system, the aorta which comes out of the heart is like our M25.
Yeah.
And then from that we have our A12, which are our arteries. Then we have our B1006 to get to Chelmsford, which this main vessel, this has got very, very thick muscular walls, because in order to come out of the heart, it needs a lot of pumping, a lot of pressure. So if these were thin walls, the walls would burst. What we need is we need to get those vessels down to an area where diffusion can take place. So everything that's in that artery, all the nutrients, the oxygen, the hormones need to come out of the vessel into the cells so that they can do their job. So there is a process of going down into smaller and smaller and smaller. So from there, I'm going to draw this very, very crudely. There is an arteriole, and off the arteriole there are capillaries. And those capillaries will feed all the way right up to these basal cells here, because these basal cells need to be fed and nourished. And Jackie, you mentioned veins.
Yeah.
Veins are the opposite.
Deoxygenated,
Yeah,
sorry, that's
so,
where I was
Yeah, you are going to have, I'm going to draw them in blue, but you're going to have these little veins, and they go back following exactly the same system. I've drawn a vein inside an artery there, that's not very clear. Let's do it back the other way. Let's do it here. And the difference with veins is they have valves rather than thick walls. And these valves will stop, they'll open as the blood flow through, and then they'll close again, stopping the blood. So it will pull here.
Very good.
And Emma, when you do skincare and you do the circulation, this will mean a lot more to you.
Yeah.
Well, I think unless you study it on a very regular basis and you're using it, so of course with skincare you use it because this is really important for the health of the cells and why we want to stimulate the blood supply. So with the heat regulation, the way in which this works is that when you get cold, your hair sticks up, The warm air, because this area has already been warmed, will get trapped and is a form of protection to keep you warm. The blood supply, however, when you get cold, will shrink back because there are more places that need it than your skin. So that's why you feel shivery and cold, because the blood's going elsewhere. But conversely, if we have too much heat in the body, how does it get out?
Sweat. Is it sweat?
A little bit in sweat. You will sweat. No, your pores don't open. They don't have doors, so they will relax and they will constrict a little bit, but they don't open as such. It's not like a door or a valve or anything like that. But I'll cover that in just one moment. What happens to the surface of the skin when we get hot?
It's red.
It goes red. Why does it go red?
Because the capillaries have expanded up to the surface in order to get rid of the heat.
Yeah. So suddenly...
Oh, it's all coming back to me.
It's coming back, fantastic. Suddenly, you get hot. There's a lot of heat in here. The heat travels through the capillaries. The capillaries now are being worked. They've got a use. So we get all of this heat. The blood comes to the surface of the skin so that the heat can radiate out. So your H is your heat. So 3 ways. What else happens when you get hot? Emma, you've just mentioned it.
Sweat.
You sweat. Okay, so where do you sweat from? What sweat?
Pores.
You sweat from your pores, yeah? They're actually holes.
Sweat gland.
Glands, good, that's the word I wanted. So let's put a little sweat gland in here.
Oh, wow, I'm gonna run out.
And then another little pore in here. So we have 2 different types of sweat. I'll come to the other one when we look at a different function. If we look at this one, which is a very simple sweat gland, that releases something out onto the surface of the skin, is called a sudoriferous gland.
Yeah.
Sudoriferous. And there are 2 types. One that is a simple water producing some salts, some minerals. Where do you think this comes from? It's come from lymph, yeah. And when lymph is outside the lymphatic vessels, it's called interstitial fluid.
Yeah.
So it basically sits within the tissues,
Yeah, just
keeping them all moist. When we get hot, it squeezes into the gland and it comes out onto the top of the skin and evaporates. And that's another heat regulation process. So already in our dermis, we've got a gland, we've got some nerve endings, we've got some blood capillaries, we've got the erector pili muscle.
There's a lot going on in there.
There's a lot going on in the dermis. It's a busy little area. And we've got our hair sitting. So let's go on now to our A. What does A stand for?
Absorption.
Absorption, yes. So our skin is capable of absorbing stuff that we put on it. Everything? No.
No.
Not everything. Some things will be absorbed down the hair follicle, into the hair and down in the hair follicle. And this is the basis of something like the Revitalash that we were talking about last week, that is a peptide that actually helps to boost the hair growth. It's also the basis of the hair retardant products that we put on the skin and we retail to our clients after waxing to help slow down the hair growth, so we can use it for advantage. Not everything that we put on the skin is absorbed. Some things just sit on the surface of the skin because remember we've got this acid mantle. So in skincare we spend a lot of time removing the dead skin cells and the acid mantle so that the peptides and the vitamins that we put onto the skin will absorb, and they'll absorb down into the area that we want them to go. Is the basal cell, because we want to influence that. We also want to influence what goes on in the papillary and the reticular area, as well as the whole of the epidermis. What else do we absorb into the body? You think?
This is a question.
Vitamin D,
Yes.
UVA, UVB rays. Or
Excellent.
things like that.
Okay. So ultraviolet light is one of the things that is able to penetrate down into the skin. So there's two things with ultraviolet light. There's the actual rays themselves, and then there's what the rays do. So the ultraviolet light will go in different depths because it is part of the electromagnetic spectrum, and therefore it will penetrate to different layers. Now, again, going back to your science lessons, can you remember that whole spectrum where you had radio waves, infrared rays, microwaves, and they're all different wavelengths. Okay. So penetrating down, I think I need to use green for that. Penetrating down to the lowest levels is UVA. And ultraviolet A is the most damaging to our skin from an aging point of view. So again, you can remember UVA is very aging. UVB will be up here by the epidermis and will cause burning. Burning. Can you remember?
Sorry, what was it?
The little structure, the little thingy that sits in the dermal layer, which helps stop the burning happening. Melanocytes. Yeah. And these are little, they look like little octopusy things with tentacles. What's that structure in the centre of a melanocyte? Melanosome. Melanosome. And it produces melanin, which travels along, what are these tentacles called?
Dendrites, whatever.
Dendrites.
Just
To play hangman with you later.
Yeah.
So little dendrites.
Yeah.
And if the dendrites get damaged or broken, then they kind of break off.
Yeah.
And that's where you then get the patchiness that causes the uneven pigmentation. So that's ultraviolet. But also, ultraviolet causes something to happen within the body, and that is the vitamin D production, which is really important. We do need that vitamin D. When you look at the process, there's vitamin D3, and there's a whole process whereby your skin absorbs it, but the actual conversion of vitamin D is done in the liver,
Yeah.
and it's stored in the
Amazing,
liver.
isn't it, your liver? Yeah, there you go.
Your whole body is quite amazing, isn't it? Yeah. But however, once you start to understand how your body works and all of these different systems and the organs within them and how the organs work in unison, it's amazing. And it really does give you a lot of insight as to how we could be living our lives. Okay, so that's absorption. Let's come on to P. P is for protection. So we're going to have lots of different colours and protection. So Jackie, the acid mantle is from secretions of the eccrine gland.
There's one that's near your hair follicle.
And there's
sebum,
one-
isn't there?
That's right, sebum. Sebum. And sebum is produced in the sebaceous gland.
That's the one.
Yeah. Draw this little gland. It's actually like a little sac. And it produces oil called sebum. So what do you think the function of that is?
But that's protection, isn't it?
It is
Sort of
definitely
coats your
protection.
hair, coats
Yes.
your skin and
How else does our skin protect us? So we've got the acid mantle, which is our waterproof covering, and that stops us from, when we get in a bath, suddenly
become full of water.
I have this lovely vision. Yeah, so we don't do that, do we? So it can't get through the acid mantle. So the acid mantle is really, really important. But so is our little melanocyte. That's really important as well, because without the melanocytes, so people that have got vitiligo, so lack of any, or albinos, They don't have any melanosomes, therefore they don't produce, or they don't have melanocytes at all. Then we're going to get a lot of ultraviolet light, we're going to get a lot of burning. So melanocytes are really key. We've already put that one in, so that's fine. What else have we got in the dermis? Think about back to the waxing classes. When we finish the waxing and we talk about a normal response, what are we talking about? What happens when you rip that skin off and rip that hair off?
Reaction.
You get a reaction, yeah, it goes red. The redness is from here.
Yeah. It's from blood spot.
Okay, so what about an abnormal reaction? If the skin responds...
Langerhans.
Okay, so we've got Langerhans cells, which are up here.
Mast
Langerhans-
cells.
Right, mast cells.
Mast
Excellent. That's the one I wanted you to get to.
Release histamine.
So we've got two policemen in the skin. We've got our Langerhans cells that are up here that are the people that are patrolling around going, hello, think there might be a problem, come and have a look.
So that's if you say get a splinter in your finger, the Langerhans are what? Go there.
They will just detect. So Langerhans cells are detectors.
Right.
They will go check things out
Yeah.
and alert the other structures in the skin that there may be a problem. So you might get a bit of redness, you might get a bit of swelling, but it might all disappear because there isn't actually a major problem.
Right.
However, when the body goes, I don't like this,
Yeah.
this is not happening, this is really going to cause me a problem,
Yeah.
there's another little structure that comes into play, which is the mast cell. I'm just going to draw it as a funny little thing like that, don't know what it looks like. I'm drawing a pretty picture. A mast cell.
A bigger dermis area.
I know, the whole board. The mast cell produces histamine, which is why when we have a reaction and then we know that there's a reaction and we actually stop doing whatever it is that we were doing, we now want to get rid of that histamine, because histamine is there to actually protect you, because it will increase the amount of blood, it will increase the amount of lymph.
Which is why you take antihistamines to stop, take away the
Yes,
rashes. So when
exactly.
you get a rash, it's your histamine going like, or your mast cells going mad, creating histamine, and you take the...
Yes, got it? Yeah. So if we put something on the surface of the skin, a cream, a product that our body does not want, it recognises it as a foreign object, influence, chemical, then the Langerhans cells will go, excuse me, Mr. Mast cell, I think, there's a problem here, do your stuff. Mast cells will release the histamine. The histamine will cause swelling, because the swelling is caused by the lymphatic system. The lymphatic system has the white blood cells. The white blood cells are the ones, and the lymphocytes, which have got all the antibodies that can solve the problem. And then you've got the nerve endings, which are highly irritated because of all this going on. There's all this trauma going on in the skin and they're going, ah, so they're being irritated as well. So when you have an allergic reaction, you normally get redness from the blood, you get irritation, and you get swelling. So yes, you're quite right, Jackie, we take antihistamines to get rid of those things, but actually we need them first of all to alert us that there's a problem, otherwise we would continually damaging our skin. Okay, so our mast cell is part of the protection. Anything else that protects us? How strong is our skin?
Moisture, not the moisture of us.
Yes, moisture will protect us to a certain degree, but how strong is our skin?
It's really strong, really. The structure itself is...
And what creates that structure?
Collagen.
Collagen. And what stops us from tearing?
Elasticity.
Elasticity. So we can stretch the skin without tearing. So it's a combination of elastin and collagen. What is collagen and elastin? What type of component is it? Okay, so we talked about this being adipose tissue. What type of tissue is in the reticular area?
Connective.
Connective tissue. Yeah. elastin fibres are like a box of elastic bands. What happens if you stick elastic bands in the windowsill with the sun? Have you ever done that?
Perish.
They perish.
They just
Our elastin fibres
lose.
perish, which is where we get our sagging and our wrinkles,
skin.
where the elastin fibres just disintegrate. That's our protection. Anything else? So we've got protection, we've got our melanocytes, we've got our acid mantle, we've got our mast cells, we've got our fibroblasts that produce the collagen and elastin. What about this down here? It's not in the dermis, but this is a bit of protection as well, isn't it?
Yeah.
What does it protect?
Muscle?
Not muscle so much.
Internal
What's
organs.
under? Internal organs, and what's under muscle? What are
The
muscles
skeleton.
attached to?
Internal
Bones. So if you've got a nice lot of fat on you and you bash yourself, you'll get a nice bruise, but you won't damage the bones. If you are very thin and you have fall, you're more likely to fracture, which is one of the reasons why elderly people are more likely to fracture. Anything else we could mention in protection? I think the hair itself, the main reason that we have hair that sits in the dermis is because of protection. So what's E?
Exclusion.
Excretion. Yeah, well done. So we excrete from this gland here, which we called
Yeah.
The
apocrine.
apocrine. And apocrine are in specific areas.
Armpits, groin, chest.
Yep.
Your sexual areas.
They
really,
are,
aren't they? So there
they
must
are.
be pheromones. It must be based on
Absolutely,
pheromones.
yes. And that's why a dog will sniff you
Yeah.
behind the legs. They'll want to lick your hands because you've got them on your sort of your wrist areas as well. In your groin area. They love licking you behind your ear. Love that, because that's how they understand each other. They sniff, they lick, they feel, because they can't speak. We can talk to each other, we don't have to lick each other to know whether we like somebody. It's slightly different. That's another reason where perfume came from. Perfume came from dabbing very strong smells of essential oils mainly, ointments, onto those areas to actually mask the smell, because this is, as I've said, an oily substance that comes out onto the surface of the skin. It's got all sorts of fats, waxes, urea, and it doesn't smell very nice, but it sometimes actually has a sexual desire smell when it's fresh, and that's the sexual attraction to people. But if it stays on the surface of the skin, it actually then degenerates, breaks down, it attracts bacteria, and then it smells foul. And that's what we call body odour, yeah, which is not particularly pleasant.
Why are some people more than others? Is that just them?
Genetically,
Is it genetic? People say, oh,
However-
eaten, can that be?
well, anything that you eat, anything that goes into your body will come out.
It will secrete.
It will
itself, won't
secrete out onto the surface of skin, which is the last one there. Is S is secrete.
Secrete.
So if you put, if you eat garlic, you will sweat garlic.
I love
If-
garlic,
Any of the very strong seasonings
though.
will come out in your urine, and it will come out onto your skin. That is part of the excretory
So
system.
onions and things like
onions,
that.
yeah. So yes, you will. If you put essential oils on your skin or essential oils on your feet, they will also come out through your body, because they will travel through the skin. Essential oils are the one thing that can penetrate very, very easily into the bloodstream,
Okay.
and of course medicines as well. So a topic,
Which is why you have to be really careful with them, with essential oils.
very much so, because they'll go through your body, they'll go through your renal system, your kidneys, through your liver,
Really?
and it can cause all sorts of toxicity issues.
Unless you know what you're doing.
Unless you know what you're doing and you know what's going on in the rest of the body.
Yeah.
Okay. So, on a blank piece of paper or on the other side, what I'd like you to do now, just to revise yourself, is using the picture as an image, turn the page over, write your sensation, heat regulation, absorption, protection, excretion and secretion, and then write as many words against each of those. So it's go back to sensation, and as much as you can write against sensation. We talked about the little nerve endings. I gave you a lot of information, some of which you don't know, but let's just see how much you can remember.
Not